Hello, in this video I'll be working through Unit 3 homework problems 8 through 13. For number 8, suppose that v of t equals 24 times 1.07 to the power t plus 6 times the sine of t represents the value of a person's investment portfolio in thousands of dollars in year t, where t equals 0 corresponds to January 1st, 2010. At what instantaneous rate is the portfolio's value changing on January 1st, 2012? So that's exactly 2 years later. We want to find v prime of 2. V prime because it's the instantaneous rate of change, and 2 because 2012 would be 2 years after 2010. So we'll start by finding v prime of t. V prime of t, for the 24 times 1.07 to the power t, we're going to use the constant multiple rule, so it's 24 times the derivative of 1.07 to the power t. The derivative of 1.07 to the power t, we're going to use our exponential rule. So that's 1.07 to the power t times the natural log of 1.07. Plus, and then for the next term, 6 sine t, we're going to use the constant multiple rule. So it's 6 times the derivative of sine t. And the derivative of sine t is cosine t. So there's our equation for v prime of t. Now we want v prime of 2. So we're going to substitute 2 in for t. 24 times 1.07 squared times the natural log of 1.07 plus 6 times the cosine of 2. Using our calculator, this gives negative 0.638. Now the units are in thousands of dollars per year. So $1,000 per year. And it sounds a little weird to say negative $0.638 thousand per year. So we can say, if we move our decimal point 3 places to the right, about $638 per year. The fact that it's negative tells us that v of t, or the value of the portfolio, is decreasing at that rate. Okay, so we're decreasing. Let's be more specific. V of t is decreasing at a rate of $638 per year at time t equals 2 years. Or we could have said on January 1st, 2012. Part B, determine the value of v double prime of 2. What are the units on this quantity, and what does it tell us about how the portfolio's value is changing? So before I can find v double prime of 2, I have to find v double prime of t. And in order to find v double prime of t, I need v prime of t. So let me rewrite that. V prime of t is 24 times 1.07 to the t times natural log of 1.07 plus 6 cosine of t. Now, v double prime of t is just going to be the derivative of v prime of t. So with v prime of t, the 24 and the natural log of 1.07, those are both constants. So using our constant multiple rule, my derivative is going to be 24 times the natural log of 1.07. That's my constant. And now times the derivative of what's left, the 1.07 to the power t. So the derivative of 1.07 to the power t is 1.07 to the power t times the natural log of 1.07. Moving on to our next term, the derivative of 6 cosine t is 6 times the derivative of cosine t. And the derivative of cosine t is negative sine t. Now v double prime of 2 will be 24 times the natural log of 1.07, but I'm going to multiply by the natural log of 1.07 again, so I can square that, times 1.07 squared plus negative 6, or minus 6, times the sine of 2. And that comes out to be negative 5.33. And our units are going to be the units of v prime per year, the units for t. So this is going to be $1,000 per year per year. $1,000 per year per year. Now, since we knew v prime of 2 was negative, that tells us that v is decreasing. At t equals 2. And since v double prime of 2 is negative, that tells us that v is concave down at t equals 2. So decreasing and concave down is going to look something like this. So we're decreasing at an increasing rate. Okay, so the value of the portfolio is decreasing at an increasing rate. At time t equals 2, or in other words, on January 1st, 2012. Part C, on the interval from 0 to 20, graph v of t and describe its behavior in the context of the problem. Then compare the graphs of the functions a of t equals 24 times 1.07 to the power t and v of t equals 24 times 1.07 to the power t plus sine t, as well as the graphs of their derivatives. What is the impact of the term 6 times sine of t on the behavior of the function v of t? I'm going to use the calculator to graph these. So here we have a of t, and it's similar to v of t, it just doesn't have that 6 sine t as the second term. And then v of t, I'm just going to do my best to sketch this. Looks something like that. So v of t is oscillating, it's increasing, decreasing, increasing, decreasing, increasing, decreasing, whereas a of t is strictly increasing. So over time, the value of the portfolio is still increasing, but it oscillates from increasing to decreasing on smaller intervals, whereas a of t is strictly increasing, but it follows the same overall trend as v of t. Now, if we look at the derivative graphs, a of t's derivative looks something like that. So a prime of t, whereas v prime of t oh, this is really difficult to draw freehand. But it's more like that, v prime of t. So again, we have this oscillating behavior with v prime of t that we don't get with a of t. So that term, 6 times the sine of t, is causing the function to oscillate. Number 9, let f of x equals 3 cosine x minus 2 sine x plus 6. Determine the exact slope of the tangent line to y equals f of x at the point where a equals pi over 4. So we start by finding the derivative of f. F prime of x equals 3 times the derivative of cosine x, and the derivative of cosine x is negative sine x, minus 2 times the derivative of sine x. The derivative of sine x is cosine x, plus the derivative of 6 is 0. So then we want to find f prime of pi over 4 by substituting pi over 4 in for x. So it'll be negative 3 times the sine of pi over 4 minus 2 times the cosine of pi over 4. and that's equal to negative 3 times 1 over root 2 minus 2 times 1 over root 2. So negative 3 over root 2 minus 2 over root 2 is negative 5 over root 2. Part B, determine the tangent line approximation to y equals f of x at the point where a equals pi. So here we need more than just the slope of the tangent line. We need to come up with the equation for the tangent line. So our equation is going to be in the form of y minus the y coordinate at the point of tangency, so that's f of pi, equals the slope, which is going to be f prime of pi, times x minus pi. So f of pi helps us find that point of tangency. F prime of pi is going to help us find the slope of our tangent line. F of pi equals 3 times the cosine of pi minus 2 times the sine of pi plus 6. Cosine of pi is negative 1, so we get negative 3. The sine of pi is 0, so we get plus 0 and then plus 6, or positive 3. F prime of x, we found above, is negative 3 sine x minus 2 cosine x, and we need f prime of pi, so that's going to be negative 3 times the sine of pi minus 2 times the cosine of pi. Well, the sine of pi is 0, so the first term just goes to 0. And then we have negative 2 times cosine of pi. So negative 2 times negative 1 is positive 2. And now we can write the equation of our tangent line. It's y minus 3 equals 2 times x minus pi. Part C, at the point where a equals pi over 2, is f increasing, decreasing, or neither? So we're going to want to evaluate the derivative at pi over 2. So again, f prime of x equals negative 3 sine x minus 2 cosine x. F prime of pi over 2 is negative 3 times the sine of pi over 2 minus 2 times the cosine of pi over 2. The sine of pi over 2 is 1. The cosine of pi over 2 is 0. So this is equal to negative 3. Since the derivative is negative at x equals pi over 2, we know the function f is decreasing at that point. So negative 3 is less than 0, therefore f is decreasing at x equals pi over 2. Part D, at the point where a equals 3 pi over 2, does the tangent line to y equals f of x lie above the curve, below the curve, or neither? How can you answer this question without even graphing the function or the tangent line? So to answer this question, we want to know if our graph is concave up or concave down, and we can use the second derivative to help us figure that out. So the second derivative, f double prime of x, is the derivative of f prime of x. So the derivative of negative 3 sine x is negative 3 times the derivative of sine x, and the derivative of sine x is cosine x, minus 2 times the derivative of cosine x. Derivative of cosine x is negative sine x. So I get negative 3 cosine x plus 2 sine x. Now at 3 pi over 2, we'll evaluate the second derivative. So f double prime of 3 pi over 2 is negative 3 times the cosine of 3 pi over 2 plus 2 times the sine of 3 pi over 2. The cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is negative 1. So this is equal to negative 2, which is negative. Therefore, f is concave down at x equals 3 pi over 2. And since it's concave down at that point, we know the tangent line lies above the curve. So therefore, the tangent line is above f of x. at x equals 3 pi over 2. Number 10, find the derivative of each of the following equations with respect to the proper variable and use proper notation. Part A, f of theta equals negative 3 theta squared minus cosine theta. Our derivative will be f prime of theta. So we'll use our constant multiple rule and our power rule to take the derivative of negative 3 theta squared. I bring down my 2 and get negative 6 theta, and then I subtract 1 from my exponent, so I get theta to the power 1. Minus, and then the derivative of cosine theta is negative sine theta, so that double negative becomes positive sine theta. Part B, g of theta equals the square root of theta plus 2 sine theta. So the derivative of g will be g prime of theta. Derivative of square root of theta is 1 over 2 root theta. So that's one of the derivatives I asked you to memorize. If you don't have it memorized, we can rewrite the square root of theta as theta to the 1/2 and then use the power rule. So the derivative of this would be 1/2 theta to the negative 1/2, which is 1/2 times 1 over theta to the 1/2, which is 1 over 2 square root theta. But we use this one so frequently, it's worth it to memorize it. Plus, and then the derivative of 2 sine theta is 2 cosine theta. Part C, f of x equals 6 square root x plus 4 cosine x. So our derivative will be f prime of x. The derivative of 6 times the square root of x is 6 times the derivative of the square root of x. And the derivative of square root of x is 1 over 2 square root x. Plus 4 times the derivative of cosine theta. And the derivative of cosine theta is negative sine theta. Actually, it's an x. The derivative of cosine x is negative sine x. And simplifying this, 6 over 2 root x is 3 over root x minus 4 sine x. Number 11, determine the values of theta at which the function f of theta equals root 3 theta plus 2 cosine theta has a horizontal tangent on the interval from 0 to 2 pi. A horizontal tangent means the slope of the tangent line is 0, which means the derivative is equal to 0. So we're going to find the derivative, f prime of theta, and then see where that is equal to 0. Square root of 3 times theta, we'll use our constant multiple rule. That's the square root of 3 times the derivative of theta. The derivative of theta is 1. Plus 2 times the derivative of cosine theta. The derivative of cosine theta is negative sine theta. So this is square root of 3 minus 2 sine theta. Now we want to know where this derivative is equal to 0. So I'm going to solve square root of 3 minus 2 sine theta equals 0. So I'm going to add 2 sine theta to both sides and then divide both sides by 2. And I get square root of 3 over 2 equals sine theta. Now knowing our unit circle, we know that sine theta is equal to square root of 3 over 2 at 60 degrees or pi over 3. That's quadrant 1. And then the sine theta is also equal to positive square root of 3 over 2 in quadrant 2. So that's 2 pi over 3. Number 12, find the limit as h approaches 0 of cosine of x plus h minus cosine x over h. This is the limit definition of the derivative. So this is equal to the derivative of some function f of x. So I'm just going to call that f prime of x. And we know in general the form of that limit is f of x plus h minus f of x over h. So what we want to do in this problem is recognize what our function f of x is equal to. So here is our f of x in this general formula. It's f of x plus h minus f of x. So above, what is it that we're subtracting? cosine x. So cosine x equals f of x. And we can check that with this other part, f of x plus h. If f is cosine x, then f of x plus h would be cosine x plus h. And indeed, it is. So those match. That tells us that our function f of x equals cosine x. Now, if our function f of x equals cosine x, then the derivative, f prime of x, is just the derivative of cosine x, which is negative sine x. And that's what this limit is equal to, f prime of x. So the key to this problem is being able to recognize and pull out of that equation what is f of x. And then you simply take the derivative of it. Number 13 is similar. We have the limit as h approaches 0, 2 times the sine of x plus h minus 2 sine x over h. So we're comparing that to that limit definition of the derivative. Limit as h goes to 0, f of x plus h minus f of x over h. So I can see my f of x in this case is 2 times the sine of x. And we can check that over here. If f of x equals 2 times the sine of x, then f of x plus h would be 2 times the sine of x plus h. And that does match what we have right here. So I know that's correct. And if f of x equals 2 sine x, then f prime of x equals 2 times the derivative of sine x, which is cosine x. And that's what this limit is equal to. It's equal to f prime of x. It is the limit definition of the derivative. So that limit is equal to 2 times cosine of x.